So today's topic is the interrupts of 8086. This is very important topic in real life also. So these are the topics to be discussed. What is the definition of interrupt? How interrupt occurs? Polling versus interrupt. Types of interrupt. Interrupt service routine or register. Interrupt vector table. Interrupt priority. Examples. And interrupt 808259 interrupt programmable interrupt controller. So these are the topics. So this is the pin diagram of 8086. In this pin diagram, we are having three pins related to interrupts. Pin number 17, 18, and 24. Pin number 17 is non-maskable interrupt. Pin number 18 is interrupt request. Pin number 24 is interrupt acknowledgement and hold acknowledgement. RQ by GTG are also related to practical applications related oriented interrupts only. So that we will see in the future slides. So here first we will see what is the definition of the interrupt. This is the definition. So interrupt is the method of creating a temporary halt during program execution and allows peripheral devices to access the microprocessor. So this is the definition. Right. What is need of temporary halt? Right. So I'll tell you with one example. So interrupt means if two persons, person A and person B, are discussing some topic. Right. So they are keep on talking, and the person C, one more fellow came, and he is having some urgent work with person A. Then what he will do? He will not talk directly. Right. He will ask the permission. Excuse me, or sorry. He will say that sorry for the interruption. Then only person A will see the person C, and he will ask, what is the work? Okay, this is the correct method to discuss to interfere with the two when two persons are discussing. So then what person A will do? He will temporarily halt the execution with the person B because person A and person B already on the job. Right? So that is what we call the temporary halt. It's not completely halt or closed or stopping. Temporary halt. So interrupt is the method of creating a temporary halt during a program execution. Suppose when a teacher is in the class, if a student came late, then what he will do? He will ask permission. Then the teacher is on the job of executing his lecture, and then this student will enter, the latecomer will ask the permission, then this teacher will stop and say that please come in. Then that is what we call the temporary halt. Right. Then what is happening? The microprocessor responds to that interrupt with an ISR. ISR stands for interrupt service routine or interrupt service register, which is a short program to instruct the microprocessor on how to handle the interrupt. Right. So microprocessor cannot execute the interrupt directly. What it does, the microprocessor responds to that interrupt with an ISR, interrupt service request or routine, and which is a short program to instruct the microprocessor how to handle the interrupt. Because there are so many types of interrupts that we will see. So this is also one more definition. The process of interrupting the normal execution of the program to carry out the specific task is called as an interrupt. Why interrupt is required? Sometimes we need to execute some specific task internally through the software also. So that's why we need some interrupt. Right. How interrupt is occurring? There are three ways to occurrence of interrupt. One is by external signal generated by the peripherals. When you connect, suppose pen drive, you are connecting pen drive to your device, then what it is showing at the bottom level, pen drive is connected, this so and so device, USB device is connected, right? And it will display the some events of that pen drive, open folder, so and so files like that. Then you have to open that folder by stopping the current file execution. That is what we call by an external signal generated by the peripheral. Next, by an internal signal generated by a special instruction in the program. Sometimes some of the instructions are in the program, and those instructions will be generated this interrupt. That is what we call the one more way of creating the interrupt. Next one, by an internal signal generated due to an exceptional condition. few conditions are there which are occurring the execution of an instruction. In these three cases, interrupts will be occurred. Okay, so this is one of the main three parameters to create an interrupt. So many types of hardware devices, including internal components and external peripherals, can send interrupts to the CPU. This is very, very important, right? So how interrupts are occurring? Either internal components or external components, or in the software programming or some other way, exceptional cases also the interrupts can be occurring. So for example, include keyboards, mouses, sound cards, hard drives, right, device drivers, and so on. All these are calls to create the interrupts. But here, typically the keyboard is at the topmost, the top of the hierarchy list, while devices like hard drivers are further down. Okay, so keyboard is the main because suppose you are seeing movie, right? So when song comes, then what happens? We will move forward. Then we will press the space bar and we will move the forward. Then that's why here keyboard plays an important role, right? But before interrupt, how the data transfer between processor and other devices or IO devices is a method called polling method. Right? What is polling method? Here you can see that polling method, the microprocessor continuously monitors, right? Continuously monitors all the status of all the keys given device. When the status condition is met, suppose if any status condition is met, it performs the service. Otherwise, it checks the next device. Then again, it will check the next device. If that device status condition is met once again, it will stop and it allows the other device information. Right? That is what we call the polling method. But what is difficulty and the disadvantage of this polling method? Right, it continuously monitors the all the devices one by one, all the keys of keyboard and all the devices one by one for every 20 millisecond or 20 microseconds of time. So it will continuously monitor. Then power will be wasted. So to avoid that, what they are doing, they have introduced the concept called interrupt method. Then what interrupt method? Interrupts are occurred due to the external devices or internal software program, not by the CPU. Where in the case of this polling, the CPU will always checks the device status. Here, whenever the device needs to get interrupted, then only it can generate the interrupt to the CPU, and the CPU hold its execution and allow the interrupts. That we will see in terms of this video. See here, this microprocessor, microcontroller, what it is doing? It is continuously checking. First it checked device A and device B, and now device C. Right? If any device needs to execute interrupt in terms of polling, then it will service that device. Otherwise, its operation will be continuously performed by the polling method. But in the case of interrupt, right, then what happens? Suppose the case of interrupt, what happens? Now see, signal is going from device to microprocessor or microcontrollers. Okay, then it handles that interrupt. I hope you understood through this video, right? So these are the differences between interrupt and polling. So interrupt devices notify to the CPU that it needs CPU attention. But in the case of polling, what is happening? Polling CPU continuously checks device status whether it needs CPU attention or not. Okay, an interrupt is a hardware mechanism. Mainly, it is a hardware mechanism. It causes the hardware mechanism, but it is a protocol. Always it checks and running by the protocol set of rules and regulations. An interrupt handler or interrupt service routine services the device, whereas CPU services the device. Here means more pain is there on the CPU in terms of polling, whereas in interrupt it is not there. More load on the CPU. So that's why these interrupts are more popular to allow the other devices when some execution or some running is happening. Right. So what are the types of interrupts? There are mainly three types of interrupts. First one is hardware and software interrupt. Second one is vectored and non-vectored interrupt. And third one is maskable and non-maskable interrupt. By using these three interrupts, once again they have given one more types of interrupts here that we can see. Interrupts are basically two types: hardware interrupts and software interrupts. Whereas these hardware interrupts only called as maskable and non-maskable interrupt. But in the examinations we have to write like this, right? Hardware and software interrupts, vectored and non-vectored interrupts, and maskable and non-maskable interrupts. Now, hardware interrupts and software interrupts we will see later. First, we will see what is vector interrupt. Vector interrupt means a series of values is called as a vector. So here all the interrupts are arranged in the form of a series of in the memory. Then it's called as vector. You see, a vector interrupt is where the CPU actually knows the address of the ISR in advance, right? But is a non-vector interrupt is where the interrupting device never sends an interrupt vector. An interrupt is received by the CPU and it jumps the program counter to a fixed address in hardware, right? With a fixed address in the hardware of the hardware, the CPU or interrupt service routine will jumps to that program counter will jumps to that address of that interrupt. Yes, that is what to call the non-vectored. But 8086 luckily having vectored interrupt that we will see later. Maskable and non-maskable interrupt. Right, maskable interrupt is a hardware interrupt that can be disabled or ignored by the instruction. Maskable means disabling, ignoring, right? If this interrupt is executed, then what happens? If some execution is happening and if this interrupt, maskable interrupt is executed, CPU can disable or CPU can ignore. But whereas in the case of this non-maskable interrupt is hardware interrupt that cannot be disabled. If a interrupt is this occurred by this non-maskable interrupt, then the CPU cannot be disabled or cannot be ignored. It has to be allowed. Suppose on the phone, suppose you are playing using your YouTube, you are seeing some videos. Then what is happening? Right? If call is coming, then immediately the execution of this YouTube will be paused, and we have to allow the call. Right? That is what we call the non-maskable interrupt. Right, so here I am giving maskable and non-maskable differences. Maskable interrupt is a hardware interrupt that can be disabled or ignored by the instruction of CPU. A non-maskable interrupt is a hardware interrupt that cannot be disabled or ignored by the CPU. When maskable interrupt occurred, it can be handled after execution of current instruction only. Right. Meanwhile, or in the middle, this maskable interrupt will not be executed, but non-maskable interrupt can be executed and the current program will be stored in the stack, right? Whereas non-maskable interrupts are used to handle low priority tasks, whereas non-maskable interrupts are used to execute the higher priority task, right? Next, in maskable interrupts, response time is very high, whereas in non-maskable interrupts, response time is slow, right? It may be vectored or non-vectored, and all are vector interrupts only. Non-maskable, all are vector interrupts only. Operation can be masked or made pending, whereas here operation cannot be masked or made pending. So these are some of the differences. So here interrupts are mainly they are categorized into two types: hardware interrupts and software interrupts. So maskable interrupts means the programmer can choose to mask specific interrupts and re-enable them, whereas non-maskable, the programmer cannot control when a non-maskable interrupt is served. Means suppose you are receiving some call on your phone, then can you stop this call? So this call should not come from the subscriber service provider. No, right? So then what we have to do? Yeah, in our phone, we have to stop the task which we are executing currently. So that is difference between maskable and non-maskable. Whereas software interrupts are here executing by instruction type INT space interrupt name like INT1, INT2, INT3 like that. So that is what we call software interrupt that we will see. And there are 256 software interrupts, and the 256 software interrupts are represented with int 0 to int FFR into 256 or type 0 to type 256 that we will see. So these are the hardware interrupts. Means used to handle external hardware. Suppose keyboard, mouse, hard disk, floppy disk, DVD. Right? These are all connecting externally. So to handle this, if some work is done by doing by this keyboard, suppose you want to move the mouse, then you need a interrupt. That is what we call the hardware interrupts. Used to handle external hardware peripherals such as keyboards, mouse, hard disk, floppy disk, DVD drives, and printers. These are all called hardware interrupts. Right. Non-maskable interrupt used during power failure, used during critical response time, used during non-recoverable hardware errors, used as watchdog interrupt. Okay, non-maskable interrupt, it is a single non-maskable interrupt NMI having high priority than the maskable interrupt request pin INTR, and it is a type interrupt. That is what we will see. So what is happening when you are trying to execute non-maskable interrupt? Right, when this interrupt is activated, these actions takes place. What is that? First, it completes the current execution that is in progress, right? Otherwise, if it's not completed, what happens? Pushes the flag register value onto the stack. Because in the flag register also we're having one flag, it's called IF flag, interrupt flag. So that's why here the status of this current execution status and the flag raise status will be pushed onto the stack and pushes the CS and IPY, because this NMI is also software interrupt, means programming. So code segment and instruction pointer are the two registers which are dealing with the programming. So that's why here these are also pushed by 2 bytes of memory locations, and IP is loaded from the contents word from the memory location, and CS is loaded from the contents of this data value and instruction value, and interrupt flag and trap flags are reset to 0. So when this operation is happening, IF and TF will be reset to 0. Right, so this is the flag register. In this flag register, pin number, sorry, this 9th bit is called as IF. IF stands for interrupt flag. So maskable interrupt means INTR. The INTR is a maskable interrupt because the microprocessor will be interrupted only if interrupts are enabled using set interrupt flag instruction. Okay, so that we are saying what is interrupt flag and set, and how to set and reset by applying 0 or 1 to this flag register is called setting and resetting, right, using some programming instruction. Then what is happening? The interrupt request is activated by an IO port. If the interrupt is enabled and NMI is disabled, then NMI will be disabled. Then the microprocessor first completes the current instruction execution and sends 0 on INTA pin twice. Then what is the meaning of that? The first 0 means INTA, interrupt acknowledgement, informs the external device to get ready, and during the second 0, the microprocessor receives the 8-bit says X from the programmable interrupt controller that we will see in the next coming slides. So here this INTA will be executed by this method. If IF flag and interrupt both are high, right, then only interrupt is accepted, interrupt request is accepted. If IF flag is 0 and interrupt, even the interrupt request is high, but interrupt flag is 0 on the flag register, no interrupt will be received from the external device. See here, that is what is happening. Suppose main program is executing and I want to execute some external hardware interrupt, then what is happening? The main program will be pushed onto the stack and pushed onto the stack using CS and pushed onto the CS and IP values and load the CS and IP values. Then what happening? Interrupt service routine will execute the interrupt, and interrupt program will be executed, and again when it reaches the IRET means interrupt return, then pop the IF and pop the CS, right, because it was pushed. Again to execute the main program, we have to pop up and we have CS because we have to go to the previous address location of that main program, and then again main program will be executed. See, upon executing IRET instruction, the microprocessor returns to the location where it was interrupted, right. After upon execution of this interrupt of the subprogram, then this IA, when it reaches IRET, then what happens? The microprocessor return to the location where it was interrupted. First it gets the program counter or IP address, because this IPR program counter only responsible for execution of the address of next instruction from the stack by popping the top bytes of the stack. So then the main program will get executed. So ISR, what is ISR? ISR stands for Interrupt Service Routine. And ISR is a software process invoked by an interrupt request from a hardware device. It handles the request and sent to the CPU, interrupting the active process. When the ISR is complete, the process is resumed. Okay, so a basic example of ISR routine is it handles the keyboard events continuously, such as pressing or releasing a key. Each time a key is pressed, then the ISR processes the input. Right? Whenever you are pressing number of keys, always it goes to the ISR and it come back to the original position. Again, come back to go to the ISR and export the current program, and it come to the next main. Like that, the keyboard is executing it. Yes, it is very important for the examination. So software interrupt. So the software interrupts are used by operating systems to provide hooks into the various functions. Means various functions needs to be executed. Then one program cannot be executed continuously. It needs to take the help of the other programs also. Then we need software interrupts, and it is also used as communication mechanism between different parts of a program. So the software interrupt is recognized by the INT, the letters INT. INT stands for interrupt. So it is a 2-byte instruction. It needs 2 bytes of memory. Right. For this, first byte provides the opcode and the second byte provides the interrupt type number that we will see. There are 256 interrupt types under this group. Right. So these are the 256 interrupts. Right. Out of 256, 0 to 4 are called dedicated interrupts. We are using in our programs. They are dedicated. 5 to 31 reserved for system use. Right. 08 in that 5 to 31, 08 to 0F are you executed by 8259 program interrupt controller, and 10 to 1F are executed by BIOS, basic input and output system. That's why int 10H for a keyboard, int 16H for a printer. Like that, we are having a printer or scanner. We are having different types of interrupts here, and after that 32 to 250 for reserved for users, and 22 3FH are executed by DOS, right? Disk operating system. Means whenever system is booting, then DOS will be executed, and whenever this DOS is executing, that is by the 20H to 3FH interrupts, and 402 FFH are open. They are still not using by this interrupts. So here, for example, I am giving every program will have. If you go through the programs, every program will have int21H. So what is the meaning of int? This is the end of the line of the program. What is int21H? Is called DOS. Call the DOS function, not DIS. It's called DOS. Call the DOS function means using MASM when we're executing the program. We to execute the program, we need to go to the DOS location. So how to go to the DOS location from the MASM environment is by the int21H. That's why here it is having two. One is called as int, and first has 2 bytes. First byte is to opcode, int is opcode, and second byte provides interrupt type number. So here int 21, int is the opcode, and 21H is the interrupt number. So this is called interrupt vector table or IVT. So here interrupts are type 0 to type 255, and int 0 to int 255. You see here, right? ISR means interrupt service routine stored in code segment. Interrupt service routine code in instruction pointer. You know that in 8086 every register is in terms of 2 bytes or 16 bits. So here 2 bytes, this requires 2 bytes, and here also it requires 2 bytes of memory location. So completely 4 bytes of memory location is required. So total how many bytes of interrupts are there? So sorry, how many interrupts are there? 256 software interrupts are there, and these 256 software interrupts with 4 bytes of memory. So each interrupt, instruction is 4 bytes. 2 bytes for CS and 2 bytes for instruction pointer. So total memory occupied by software interrupt is 256. 4 is equal to 1024. 1024 means 1 kilobytes of memory is required. So to execute this to store this software interrupts, we need 1 KB of memory in ROM memory. I hope you understood. See here, instruction point type 0 instruction pointer is 0000 and CS is 002, but between 000 and 0002 and 001. So instruction pointer memory location addresses are 000 and 0001, whereas code segment is 0002 and 0003. So like that you can understand this. So steps involved in processing an instruction execution. So execute the interrupt instructions, right? Jumps to the interrupt vector table, go to the interrupt vector table where that interrupt is available. Then takes the code segment and instruction pointer in the vector table as I shown in this table. Pushes the existing CS and IP on the stack, current CS and IP onto the stack, and loads the new CS and IP to means the subprogram to execute the interrupt loads the CS and IP, jumps to the interrupt service routine and execute the interrupt service routine and come back to the main program once again. So as I have shown already this flow. Right. So software interrupts of 8086. So it is a 2-byte instruction, and I told you already. So these are written as int 0, int 1, into 2, into 3, and into 4. But here I am showing it as into 00, into 01, into 02, 03, and 04 because it's a 2-byte representation. So here we are having 256. So 256 can be represented using FFs. So that's why the first 00H. FFH 00H to FFH. Otherwise, it can be written as into 0 also. Right. So here I have given software interrupts 002 0FH are called as the dedicated. Okay. So what is a type 0 or into 0 interrupt? Right, it is called as type 0 is called as divided by 0 error. Right. Means if the 8086 will automatically do a type 0 error interrupt if the result of a division operation is too large, right? 1 by 0 or anything by 0 is equal to infinity to fit in the destination register. So that's why then this type 0 will be high and it will be executed, and it shows that the result will not be shown because it is infinite value, like that it will show. Right? That is what we call the type 0 interrupt. Next, single step interrupt, it's called type 1. So the use of single step execution feature is found in some of the monitor and debugger programs. So I'll show you this step in the execution at the time of execution. So when you're pressing F8 or F8, then it shows the step-by-step execution of the every step of the program. So then that is because of the type 1 or a single step interrupt execution. Next one is type 2. So this type 2 only called as non-maskable interrupt. So 8086 will automatically do a type 2 interrupt response when it receives a low to high transition on the NMI pin. Means whenever NMI is high, whenever NMI is high means it goes to the low to high signal on the NMI pin on the on the 8086 IC. Then this type 2 interrupt or non-maskable interrupt will be automatically executed. Right. When it does type to interrupt, the 8086 will push the flag onto the stack and reset the trap flag and interrupt flag and pushes the code segment value and IP value for the next instruction on the stack. So in this way, this non-mask interrupt will be executed. Right. So type 3, this is very important. Instead of in21, sometimes and some people write this into 3 or into 3 in the programming. So it means it is type 3 is produced by execution of the instruction. The main use of type 3 interrupt is to implement a breakpoint function in the system. Means you're writing suppose 100 lines of program. Suppose you need breakpoint sometimes, then we need this into 3 or type 3 in the programming. We will write, you will see this into 3 or type 3 in our programs also. So type 4 is also called int-o or overflow interrupt. Right, if 8086 overflow flag will be set in the flag register, we are having overflow flag. If the overflow flag is set, when overflow flag is set, whenever you are performing signed operations, this overflow flag will be high. Right, because in the signed operations, if it is 8-bit, only 7 bits are manipulated and 8th bit is representing signed values. If there is a carry from bit 6 to bit 7, then that is known as overflow. Then that will be represented by using this type 4 interrupt. Okay, so this is the process of interrupt execution that we have seen. So example of some interrupt. So interrupt to end of the code segment, move h comma 4c and im21h. We will write in our program these instructions. Next, example to clear the screen in C language. So how they are writing the program in the C language using interrupts. You see, move AH comma 00. AH is the higher byte of your AX accumulate register, and move AH comma 0 to this. Move AH comma 0 to indicates clear the screen. And I told you int NH is screen related or display related interrupts. Okay. Next, interrupt to place the cursor. Now this is the cursor. How we are placing using mouse or any other pointer? How we are placing this using this int 10h only. Then this is the program to place the cursor. Where in terms of rows and columns we are placing this cursor. Now we can disable. Sometimes we can disable some interrupts also. Why we need to disable some interrupt? Whenever we want to execute one by one process, right? So then sequential fashion, then we need to disable some interrupts. Okay, so processor will ignore further interrupts while processing one interrupt. Okay? Then we can disable the second interrupt. Right, interrupts remain pending and are checked after first interrupt has been processed. If first one is completed, then it goes to the next one. If second one is complete, then it goes to the third one. Like that only it will be executed. So for that we need this concept called disabling of interrupts. Okay. So here you can understand what is disabling of interrupts. See here, owner is handling the first customer. Then it is then if it is done, then only owner will handle the second order. Okay, so this is but does not take into account relative priority and time critical needs, right? So what is the disadvantage of this interrupt? What is the thing of interrupts is here when sometimes want to execute some interrupts when time critical is there, then this disabling of interrupt is not always good. Then we have the interrupt priority. So based on the priority of the interrupts, we can execute, not in the sequential order. Okay. So here you can see that each device is able to originate an interrupt request. Sometimes several sources can request simultaneously. We cannot say that these interrupts will always execute sequentially. Right. So sometimes when some operation is going on, then sometimes hardware, sometimes software can execute internally based upon its priority or its importance. Then this priority came into the picture. So what is interrupt priority? A priority interrupt is a system that establishes a priority over the various sources to determine which condition is to be serviced first. When two more requests arise simultaneously. Okay, so that is the need of this interrupt priority. Okay, so that I'll show you with one video also here. Suppose a worker is there and manager is also there. Please help me with this work. Manager is asking the worker. Okay, and he said okay. Then he is keep on working. Then co-worker came. Hey, please help me with this work. He said all right, but we will not do right now. Okay, and he is thinking first I have to do manager's work or I have to do co-worker's work. Okay, then he is thinking that who is the more priority, manager or co-worker? Right? He think that manager is having the higher priority than co-worker. Then he start doing work of the manager. But suddenly, executive director came. Right? Then executive director has given some work to this worker. Then what he is doing, and he is thinking, I have to do manager work or I have to do executive director work. Okay, then now priority goes to executive director then manager according to their uh, post. Yes, so then the interrupt priority came into the picture, and this concept is also very important for the examination. That's why here I am giving interrupt priority table, very important for the examinations. So here, right, into zero, all the software interrupts are having the higher priority than hardware interrupts. Okay, divided by error zero, int n, int overflow, all are having the high priority, whereas non-maskable interrupt is the next high priority. Then interrupt request is the least priority, whereas single step execution is also the lowest priority, because we need to execute one by one. Okay, in the single step, that's why it is the least priority. So interrupt priority in 8086, as far as interrupt priority in 8086 is concerned, software interrupts are they having the highest priority, followed by NMR, followed by INTR, whereas single step has the least priority. So what is need of priority? Based upon sometimes we need to execute some operations based on their priority levels, not by the sequential level. So here how interrupts are executing. Till now we have seen in the pin diagram only INTR and NMI. But there are so many devices can be connected to your CPU or some laptop and so on. Then how this number of devices or number of devices inputs can be handled. That's why we are having one IC for this interrupt controlling. So that is called as 8259, which is known as programmable interrupt controller. So this is the diagram of interrupt controller. So here we are having, first we are having interrupt request register. So all the interrupt request in the pin diagram we are having INTR interrupt request. So here we are having 8 interrupt request, means it can serve up to 8 devices, IR0 to IR1 and IR7. So then we are having interrupt service routine or interrupt service register, right? This is a program. Next, the priority resolver. Here the priority will be taken out of this 8. Here the priority will be taken by this priority resolver. And interrupt mask register, we will see what is that, right? And data bus buffer, read write logic, and cascade buffer. Here this is the pin diagram of 8259. So here you can see that there are 8, and this is the pin diagram of 8259. So up to 8 hardware interrupt devices are supported time. It can support and it can receive signals from 8 hardware interrupts. But these 8 hardware interrupts are having some priority. Based upon that priority, the signals will be received by this 8259 to 8086. Then it will not take from IR0, next IR1, not IR2, like that. It will not take one by one. Okay, and see here this highlighted position, the highlighted blocks only can interface with 8086. 80 means read write logic. 8086 also having RD signal, WR signal, address A0 bit, interrupt acknowledgement, interrupt request, D0 D7 data bus buffer. So this highlighted one is also called as the portion of 8086. Remaining portion, this portion is called as and 8259 IC main blocks. This is the heart of your 8259. Okay, and these signals are used to interface to the 8086 microprocessor only. Right. What is interrupt mask register? Here you can see that. So the logic block mask interrupt lines based on programming by the processor. It prevents masked interrupt lines from interrupt the processor. As I told you, there are two types of hardware interrupt: maskable and non-maskable. If there is any maskable interrupts, then this that will be handled by this interrupt mask register. Means it will disable the or stop the current. It will continue the first the current program execution will be complete, then only it will allow the second one. Okay, so such type of interrupts can be masked by this interrupt mask register. So this is the connection between 8086 and 8259, AD0 to D0 to D7, AD0 to AD7, like that connections are there. So they are two-way arrows. Next, here we are having interrupt acknowledgement, and that is connected to 8086 or 8088 interrupt acknowledgement, and we are having interrupt request in 8086, and here we are having INT signal, right? And the signals are coming to the 8259 from the external environment. If more than 8, then 18259 will not be solved. That's why here we are taking 2. So this is called as master 8259, and this is called as slave 8259. Means high interrupts will directly connected to 8259 directly from timers and from keyboard controller. You can see here they are connected to IR1, and remaining IR3 to IR7 are coming from slave or the second 8259, because one 8259 can serve only 8 IR0 to IR6. More than that, see here I am having again one more 8. Okay, then from this master to CPU it is going. Okay, from this master to CPU it's going, means it is the connection between this master and 8259, and this is the connection between master and slave 8259. Same pins are there, but slave cannot do any operation by itself. It will always follow the instructions of the master. Okay, and this is also one more connection. So 8086 and master of 8259 is connected to 8086, and this master is receiving some signals from INTR. Low priority signals and low priority devices are executing through this slave 8259. Okay, thank you. If you have any questions, please feel free to ask me, and thank you.